Welcome to the DIY water channel. Today we are going to be making a charcoal water filter. A charcoal water filter is a portable water system that is different from other systems because its main component is charcoal. This enables it to filter out contaminants more efficiently and in a better manner. Now for the materials. So the materials list is not very long. There are very less things you're going to be needing, and most of them can be found in your backyard or at the beach. The first material is cloth. Any sort of cloth, a t-shirt, an old sock, an old pillow cover, anything would work. Otherwise, you could use tissue rolls like this, or you could use cotton, which are both readily available in almost all stores in Lomé. You don't need to go to stores actually, you can just find this at your house. Next thing, which is sand. This can be found at your local beach very easily, and there is no problem with sand. Small pebbles as well as large pebbles can also be found very easily in your backyard or at the beach. Charcoal. Charcoal can be found at any fireplace where food is being cooked using this charcoal. Otherwise, you would have to buy the charcoal because making your own charcoal is a very difficult and tedious process which I do not want to get into. And finally is plastic bottle. Such a plastic bottle, which is a 1.5 liter one, is readily available in almost all stores as well as in your house. In fact, even if you go to the beach to collect the sand, you will see plastic bottles lying around. It doesn't have to be as big as this one. This is a 1.5 liter bottle. It can be smaller, a 1 liter or 500 milliliter bottle. It's not a big deal. All we need is for it to function. If you want, you could do some modifications to the procedure, which I'll be talking about next. And if you do some modifications, you may need to change your materials up a little bit. But I will leave this up to you. Now for the procedure. So first, we're going to need to cut the bottom of a plastic bottle. So you can see I've already done that. And once you cut it, you're going to need to put a cloth inside first, like this. That's when you stuff the cloth and make sure that it's tightly sealed so that nothing can come outside, like this. Next, you're going to want to add your charcoal in, not too much. As much is enough, as you can see. Much charcoal is more than enough. A little bit more, you can just add the whole thing. Okay. And once you have the charcoal, then you can add the sand. There we go, the sand is inside. Add a little bit more sand. There we go. Now we add the small pebbles like this. There we go. Just a little bit of small pebbles like this. And now for the large pebbles. So the large pebbles and small pebbles, they don't have to be too different. You just have to be like very different so that they can be filtering out the contaminants at different layers better. So here we go. I don't know if it's clear, but these are the different levels going from the plastic or the plot all the way up to the large gravel. So now let's test it out. It really works. Now to test the water, what I'm going to be doing is I'm going to be using these 6 samples of water, which is seawater, factory municipal water, house wastewater, borewell water, rainwater, and atmospherically condensed water. I'm going to be using these 6 samples of water, and I'm going to be using 1 cup each of these samples, and I'm going to be putting them through the filter, and I'm going to see how the water turns out at the end. So what I'm going to be doing, for the sake of efficiency and for the sake of equity, I am going to be changing out the materials every time I finish filtering 1 sample of water. So I'm going to be doing this for 1 sample on camera, and I'm going to be doing the remaining off camera to save time. So let's do it. So this is seawater. I'm going to pour a little bit of the seawater into this. 1 cup, as I had said. This is 1 cup, and I'm going to pour this 1 cup into the filter. Very slowly, because it can drip. There we go. 1 cup has gone in. And now we just have to wait for the water to finish filtering. So there are some things that I would like to tell you about this filter while this is happening, because this is a very long process. First of all, this filter, the water that turns out at the bottom, is going to be cloudy and not good to drink. So you should not drink this water at the end. First, you should sterilize this water, and sterilizing just means to clean the water of any microorganisms. So the best way to do it is to boil the water, or you could use chlorine or iodine tablets. But for the sake of cost, we're going to be boiling this water after it finishes. Not only that, it is also important for you to change out the materials in these filters in 2 weeks, because the materials inside are going to start to absorb the contaminants inside the dirty water. And so it's important to keep changing these materials time to time so that the materials and the water that you get are still clean. So now we have to wait. And while we wait for the waters to finish filtering, I'm going to be telling you about the advantages and disadvantages of this filter. So the first advantage is it removes chlorine. Chlorine, a very dangerous chemical that could cause poisoning and even death to people. So this filter actually removes chlorine. It also removes particles such as sediments and volatile organic compounds. And it improves taste and removes odor. It is inexpensive. In fact, all the materials together wouldn't even cost you about 2,000 sefa, except for if you were actually going to go and buy the charcoal and the sand, which is not recommended because you can find all these materials very easily. It is also very easy and effective to make this filter because all you need are household items or items you can find locally at the beach. Also, the water that is gotten at the end of filtration as well as sterilization is very clean and nice to drink. It is visually clean as well as with smell. It reduces some bacteria and viruses, though not all of them are removed until we don't sterilize the water. I am not going to be counting sterilization as part of this filter because all this filter is doing is filtering out the water. So that is why this is one of the negatives. Without sterilization, microorganisms are still present inside the water. This filter is also very time consuming for large quantities of water. If you are filtering about 1 liter of water in 1 day, this filter is very good. But if you're going to be filtering a lot more water, like if you want this water to be your water supply on a daily basis, this filter is not very good for that. It does not kill all bacteria and parasites. For example, Cryptosporidium is not killed, which is a very dangerous virus, very dangerous bacteria, which could cause a lot of problems and even death. And also, it requires you to regularly change the materials inside the filter. This is a very difficult job for some people because they do not want to be doing this every time. That's all over here. Let's go and check out how our filters are doing. So guys, it's been about 4 hours, and here we have our 6 samples from the 6 different water filters respectively. Our next step is to sterilize these samples, and to do that we're going to be boiling them. But before we continue, I would like to show you some of the modifications you could make to your water filter if you please to. Let's say you wanted it to be on a tabletop, which is easier to be able to filter it, and you wanted to put a bigger container that had a wider mouth so that it could be more efficient for you. What you could do is you could use something like this, which is a wooden board, and what you could do is you could take this filter and prop it on over here, glue it, and then it would be really good for you to use that way as well. This is one, but then you could also, if you wanted it to be propped up on the wall, as in you would pour the water in and it would come out, but then you wouldn't have to hold it and move around with it. It would be on the wall. What you could do is you could use sticky tack, or you could use some pins, and you could pin it onto your wall. If your wall is like mine, which is like concrete, what you would have to do is you would have to use nails or use super glue, and you have to glue it on. However, I don't recommend this since it is really difficult to be able to manage it and to remove the materials inside and be replacing them every time. Let's say that the amount of water you're getting from this is very minimal and it's not enough for you. What you could do is you could use bigger baskets, bigger containers, as wide as this, for example, and you would have to have 2. And then what you would do is you would glue this, as you can see right now on your screen. You would glue this down over here, and you would glue it in the middle of both of them, and so it would be better for you to use it this way if you wanted more gain and you wanted it as a complete system. So yes, these are some of the modifications you can do to your water filter to make it more personalized for you. So let's get to sterilizing. So guys, here we are in the kitchen and we are going to be boiling this water. First sample, which is salt water. You can see I poured it in. Sample is quite minimal, so we're not going to be using a lot. And so we've covered the top. Now we're going to switch on the gas and we're going to let it boil. That's a rolling boil for about 5 minutes. So we're going to let this boil, and I'm going to boil the other 5 samples as well. And then we are going to come back and we're going to do the smell test and the sight test. Okay guys, we're back. We finished boiling all the samples of water, sterilizing them. Now it's time for our initial tests. So for the sake of safety, I'm not going to be tasting any of these samples, and I'm only going to be giving a sight and smell test. So let's start off with sight. So comparatively, these samples are very, very different from the original colors. The rainwater, as you can see, is become way lighter and way cleaner. There are almost no contaminants inside. The house wastewater, which I would say is the dirtiest looking of all of them, still has a very yellowish tint to it, but it is not very dirty anymore. It is way lighter than before. The atmospherically condensed water has stayed the same almost, because the original one was not so dirty. The finished product is also not very dirty. It's the only thing that might have changed is that the visible particles of sand and rocks, those are absent from the finished product. For the borewell water, it is way cleaner than its original state. It is no more having an orange tint, and it is almost pure, visually of course. The sea water is also very close to borewell water. It's visually looking very clean, and if the person did not know where the source of this water was from, they would mistakenly drink it. The factory wastewater would rank second in the dirtiest looking one because it has the yellowish tint that it had originally. It is just lesser. Now it's time for the smell test. I'm going to be taking each of the samples and smelling them and telling you how they smell. The rainwater has almost no smell. I cannot get any scent from it, which is normal in clean water. The house wastewater has a slight soapy smell to it, so I would say that it's not completely clean. The condensed water has no smell as well. It's like the rainwater. The borewell water also does not have any smell, and neither does the salt water. The factory wastewater, however, still smells a little bit like diesel oil and petrol, which I think is normal because we find this in these factories. So from these initial tests, what I can conclude is that the house wastewater and factory municipal water, those two are the dirtiest and have not successfully gone through the cleaning process in the charcoal water filter. And the remaining ones, I would say they are ranking to that level at which you could say that you're safe to drink. However, I am going to be sending all of these water samples to a lab for further testing so that I can better understand if they are clean to drink or no. Until then, see you. But before you go, let's do a small recap of what we've done today. Today, we have built a charcoal water filter that is effective at cleaning dirty water and rendering potable water to you. The materials needed to build this filter are sand, charcoal, small pebbles, large pebbles, plastic bottles, and cloth. A tip for the charcoal is that the finer it is, the better this filter is going to work. The procedure. The first thing to do is to cut off the back parts of a plastic bottle and stuff the neck with a cloth. Then add fine charcoal, then sand, then small pebbles, and finally large pebbles. To make this filter work better, add alternating layers of charcoal and sand before adding the small pebbles and gravel. Once the water is finished in filtering, sterilize the water by boiling it for up to 5 minutes on a rolling boil. Some more things to know about this filter. The charcoal filter helps the environment because all the materials are either recyclable or are already found in a natural source. Also, it's important to use water from a relatively clean source if it's possible because that would render the water cleaner than if it was dirty. The larger the container of the plastic bottle and the bigger the layers of the charcoal and sand, the more effective this filter is going to be. Finally, if the water tastes flat after sterilization, pour the water between two clear containers and taste it again. If it still tastes flat, add a pinch of salt to the water and it should be good to go. Thank you and see you next time.